This is a preprint that we're going to have to follow up with and monitor because it has significant implications for wastewater monitoring. So qPCR, or quantitative PCR, targets two regions of the nucleocapsid protein in COVID, the N1 region and the N2 region, where the expectation is that these exist in a 1-to-1 ratio. However, a discrepancy between the two biomarkers has been noticed by many groups using this method since late 2021, where specific mutations in the N1 probe target can cause a significant drop in wastewater signaling, resulting in significantly lower N1 copies relative to N2 copies. And as COVID has continued to mutate from period 1 to period 2 to period 3, we've seen increasing numbers of mutations in the nucleocapsid protein, which we had assumed to be pretty stable. Because the major mutations in COVID happen in the S gene, the spike protein, where most early variants of concern, including alpha, beta, gamma, and delta variants, have no mutations in the N1 or N2 regions, with this being the nucleocapsid protein. Another example. However, with Omicron and its sublineages starting around late December of 2021, it had several mutations to the N1 probe binding region, notably a C to T point mutation at this position. Moreover, additional mutations appeared in the N1 probe region in certain BA5 sublineages and the BQ lineages, where this study looks at weekly wastewater samples from Toronto and Ashbridges Bay, where the data unequivocally confirms the observed N1 dropout or discrepancy between the N1 and N2 signals, which is due to strain-dependent mutations in that probe region, where this is now universal to all Omicron mutations, which is what everything is currently, is the lineage of Omicron, resulting in concentrations that were all lower compared to the true concentrations, where this figure is a timescale showing the period of no mutations early on, then one mutation, which is when we have our Omicron, and then more mutations over time, resulting in a higher N2 to N1 signal. Meaning that if we look at the correlation coefficient between the two, using standard Omicron, the red here, with this black reference line, which would be the 1-to-1 correlation, meaning that if you have like a concentration of 8,000, you're getting 8,000 as the true copy number. So for Omicron, the red, if we go for 8,000, instead of getting 8,000 like in the black, we go over to the red, that's the measured value of 8,000. The true value would actually be 12,000, which is a massive discrepancy, meaning that the current numbers are massive underestimates. Where for just the standard Omicron lineage with just the one mutation, there's about 25% depression of the values. And if we have more mutations, where this ratio goes even more out of whack, this is about half the actual value. So if we do that 8,000 again, it's almost 16,000. 16,000 is the true value when we're only measuring about 8,000. Where this study demonstrates that both the number of mutations and the mutation position on the probe binding region influence the amplification of the N1 target. So it has to be in a specific location, and then also the higher the degree of mutations, the higher the deviation from the measured and true value. Now, we need to wait for peer review to fully accept these findings, but from what I can tell, this looks legit. And it would mean that we would need to apply some sort of back correction to our wastewater numbers to get what the actual values of them are, meaning that all of our numbers that we've seen would be much higher than what is currently reported.